your experience for the lab. And let's see here. Okay, so station 1 is one we're going to start with because it's one that you're going to get to see throughout the lab. And I will always try and show you like the reactants before, and then the during for some is like right away, and then for some of them there's a true after, like if I'm testing for a gas, or if it's like I keep coming back to it like this one, there'll be kind of, you know, you'll have plenty of observations to record, but just so you're aware of kind of like the process. So station 1 talks about a piece of copper wire. Now, if you guys were doing it, you would not use quite this long of a piece. You would just use a small little piece, but this is copper wire. And oh, the other thing, I meant to say this, my bad. Okay, so for the lab, on the predicting products worksheet, you know, it'll say in words like solid copper is added with silver nitrate solution, okay? And then you have to predict the products and whatnot. You're going to use your observations. This one's pretty obvious. Like, here's a piece of solid copper to determine states of matter. And then silver nitrate solution, you're going to then have to write the state of matter based on what it is. Now, for the products, you have to predict the products, but then to determine state of matter, you have to kind of use your observations. Like, there's not going to be anything that's going to tell you what state of matter something was. It's using your observations to help you with that. So, piece of copper, and then the silver nitrate solution here is in an amber bottle, and that's because silver nitrate is light sensitive, and so it's kept in an amber bottle to kind of prevent it from reacting with ultraviolet radiation. So this is what it looks like out, and just so you have a comparison, I'm going to put this piece of copper in the test tube here. Here's some bleach that we'll use later, and just see, I'm going to get a dropper full of that and a dropper full of the silver chloride, so you have like a comparison here. And I'm also going to put this magnifying glass, because sometimes my phone doesn't want to focus on it, but there you have a visual. And it's really good when you are describing stuff, is if you aren't familiar with it or you don't know how to describe it, having a reference point is helpful. So me showing you a different liquid there is the case. Now, all of these, the solids, what's in solution, what's a liquid, everything here is at room temperature. So everything that I will show you as the before, temperature-wise, is going to be all room temperature. Odor, on some of them I'll try to remember if I think that there is a notable odor. The silver nitrate, it does not have a noticeable odor. I am smelling bleach because I did drop a drop of bleach down. It just smells fresh. And so I'm going to add some silver nitrate to the test tube with the copper wire. And you guys would just add like a little piece and like a dropper full. I'm going to add a few dropper fulls so you can get like a little bit more. But the directions say just add like 1 or 2 dropper fulls. You don't need a lot of something to see a reaction. I'm making this reaction, putting more in than you guys would, so that you can see it a little bit better. Now, this is right after mixing, and I have the copper wire above, and so you can compare like the copper wire not in the solution versus the copper wire in the solution here. And this is with a magnifying glass. Hold on, I need to tighten my phone up a little bit so that's not so shaky. There we go. You're getting a really good visual here of the copper wire in the silver nitrate solution. And this reaction we'll come back to because it will change over time, but it's really pretty for the first minute or so just to watch it. Here's a good view of it. It's alive. It's not really alive, but it's pretty. Get a really good, so like your eyes would just see it as, hold on. Trying to get that in focus, now it won't. Well, we'll come back to it, but it is very pretty. So that's station 1, before and during. The after can be any of the remaining times I'll show it to you. Station 2 is taking a piece of magnesium metal. So here is the magnesium metal, and it's very bendy, shiny. It's a thin piece here, and it is kind of, it's not like super sharp, but it's definitely has rough edges on it. And I'm going to light this in a Bunsen burner flame. Now, I'm going to do it a couple times. So let me light the Bunsen burner here. This is also station 8. So station 8 says observe a Bunsen burner. So here's before with, I'm going to turn the fuel line on. So I'm going to add methane gas. You can hear it maybe, like a slight rush. And me lighting it, adding a little bit of activation energy. So this is methane gas burning in the air. Here is the during. If I turn off the Bunsen burner, cut off the supply line, that'd be the after. So you'll see the Bunsen burner is going to be on now for like a while. So if you see observations that you want to make with methane burning in the air, there it is the whole time. Okay, so station 8 is just like ongoing because I'm using the Bunsen burner for many stations. But I'm going to take this magnesium and burn it in the air. Now, we're going to view it with our naked eye, and then I'm also going to put this piece of cobalt glass over my phone, not with my hand in the way, sorry, as a filter, because you can actually see something different when you burn this with the lens versus without it. Now, if you're in person, it does say don't look at the magnesium piece directly, and that's a good advice. It's going to be very bright. I don't know how it will translate over the screen in terms of like, I mean, you're probably going to look at it directly anyway, but a good technique, if something says don't look at it directly, is you stand, you know, like I'd be standing here and like looking like forward, but I'd see it out of my periphery. Like I can, if I look a little bit, like I'm staring at my chair and I can see the Bunsen burner, and that would be a good lab technique. Now, you guys are just going to view it. I'm not going to look at it directly once it starts going, but I'm going to do a small piece, not with the cobalt glass, and then I'm going to do the big piece. I'm not going to waste the big piece without the cobalt glass. So this is magnesium burning in the air there. Beautiful. Now, the after here. Sorry, let me put this full on. Now you can see the part that's kind of charred versus what the tongs are holding. And I'm going to bring that down to this little watch glass here. And as I set it down, you can see that it just kind of crumbled there. And it is like sorry, trying to put the other lens on so you can see it. There it is. So you can see the part that I was holding is on the far right, and then the part that was put in the flame there, the after. It's definitely a powdery, flaky substance. Now this big piece of magnesium, I'm going to put my tongs in as well. And we won't see, it'll look like real similar at first, but at the very end, we're going to see another color that magnesium gives off that you can only see when you look at it through cobalt glass. So this is a piece of glass, but it's infused with some cobalt ions, and cobalt is this beautiful blue color here, but it's just a lens. So again, I'm going to light this magnesium, and then we're going to view it with the cobalt flame, and at the very end, you're going to see right there. Oh, that was so pretty. The beautiful rose pink color that you saw, that is, you can only see that if you look at magnesium burnt through cobalt glass, because your eyes get kind of like, get over inundated with the brightness that your eyes without that can't see it. And so that's actually a lab technique that now the other chemistry teachers at West High use. So I shared it with them. And here is the big piece after it's burnt. And I'm gonna set that down in the watch glass right here. Don't you guys see it? This is the after. Oh, there's the piece that was burning oh so bright. And then I'll just kind of touch that with my finger, and you can see how crumbly it is. Now this part is not crumbly. It's not as shiny, but it didn't get like the full burn there. And what that did. So that's the after. The during was obviously, when you saw it, ablaze. It's pretty though. Okay, that's station 2. Let's take a look at our station 1 here. Even though it's only been a couple minutes, there's still a lot to see with this one. So, oh my gosh, it's so pretty right now. This is like my favorite stage that it's in. Hold on. No idea why my phone's being so shaky at this moment in time. Hold on. Try and tighten it again. There we go. So that is the silver nitrate solution with the copper wire. Yeah, this is about as pretty as it's going to get. I will show it to you, another 20 minutes, 10, 20 minutes. And hopefully you can see that slight hue to the solution as well. I'm going to hold up another one here in just a second for comparison purposes, but you can kind of see that. So station 3 here, and just to hold up a different solution, a translucent one as well, there's definitely a hue to this one that the bleach does not have. So that's an important note for station 1. All right, station 3 talks about getting a test tube, adding some hydrogen peroxide, and hydrogen peroxide is also light sensitive, so that's why this bottle is wrapped in aluminum foil. So I'm going to pull it out so you can see it is just a translucent liquid. But if you notice, if you have hydrogen peroxide at home and it's in like a brown bottle, again to try and make it so that it's not exposed to the light because it's light sensitive or it reacts with ultraviolet radiation. Same with like milk. Milk will spoil faster, and that's why milk is kept in the dark. Those containers that milk is in, if you've ever noticed, are typically opaque. And that's to prevent, and then your refrigerator, I know the light turns on when you open it, but guess what? The light is not on when the door is not open, if you did not know that, because food that's kept in the refrigerator should be kept dark so that it's not being exposed to unnecessary ultraviolet radiation. Fun facts of the day. Okay, or chemistry knowledge of the day. Here is some hydrogen peroxide. I am going to add bleach here, which is sodium hypochlorite. That's the active ingredient in bleach. Oh, the hydrogen peroxide odor-wise, let me see here. It does not have a distinct odor. It's not, I'm not smelling anything super dramatic. So the during is going to be right here when I add the bleach, and I'm going to see that here. There's definitely a fizzing and a bubbling. The test tube feels a little bit warmer. And get you like a little close-up of that. Small bubbles forming. The rest of the test tube looks pretty much the same. This one says to test it with a glowing splint. So I'm gonna set this here. So I'm gonna burn this for a little bit and then blow it out so that it's glowing. You might remember this from like the second day. And then I'm gonna put that in. Oh, that's fun. I'm gonna blow it out again. It's out. Put it in my test tube. Oh. Well, you can see it just glowing brighter. I'm gonna add a little more bleach. Put that back in. Oh, there was a nice little pop. And there it is. I'll blow it out one more time. So that's how you test with a glowing splint. And the solution's still bubbling. There is more condensation up here. That's a good note. And it's also for comparison purposes, what happens if I put a glowing splint in a test tube that has nothing in it? Let me grab a clean test tube over here. So, right, you need to know what does a glowing splint do in a test tube that has nothing in it to know if what I just did is unusual or, you know, typical. So, burn the splint, blow it down so it's glowing, put it in. Oh, shoot, dropped it. That's seen, that's, oh, let me do it again. Put it in, pull it out. It's still kind of a glow. I'll put it in again. But hopefully you notice when I do put it in that the glow kind of does weaken there. So this had nothing in it before, just a normal test tube. And if I do a burning splint in a test tube, so you know what happens as well. Again, a reference point, an anchor point, so that when you see a burning splint or a glowing splint go in test tubes and they do something different or the same, you have kind of a reference there. So there's that. And then here, again, these are just two, this is from station 1, just to show you like visually the tint on station 1 versus this one, which just had the hydrogen peroxide and the bleach there. So it is, I mean, who doesn't want to look at this? It's so pretty. It won't stay pretty forever. All right, that's station 3. Station 4 talks about sodium, taking some sodium hydrogen carbonate, aka baking soda. So here's what baking soda looks like before. Definitely has a nice fresh smell. It's a very, very thin, fluffy powder. And I'm going to put some in a clean, dry test tube, which this one's not as clean as I would like it. I don't know. I spilled some stuff in it. I'm going to grab a different one. Make sure it's sparkling clean and dry. Okay, so dry test tube here. That's important. And I'm going to add some sodium hydrogen carbonate. It says to add a couple scoops of it. So scoop with a scoopula, and then putting that in the test tube. This is probably enough, but I'm showing like what a scoop in a test tube amount is, because sometimes students are like, oh, is that enough? Do I need it more, less? It says, I believe 1 to 2 scoops. I'll add 2, and this is more than enough to see what we need to see. And so just so you guys are aware, like you don't need a lot. Now I'm gonna put a little bit back just to show you like, oh wait, well now I dumped it all, my bad. Now a little scoop like this, that would probably not be enough for this reaction, just to visually see it. Now, would it be enough for the reaction to occur? Absolutely. But just showing you guys that this is qualitative. We're not massing anything, and that's perfectly fine because we're just classifying reactions and trying to see what happens macroscopically with the substances. It talks about this being hooked with a test tube clamp. So test tube clamp here. I'm going to open it and clamp it. Now, whenever you're heating something, you want the clamp to be at the top of the test tube. You do not want the clamp to be down at the bottom or even like most of the way. You want it all the way at the top. And if your test tube has a lip, and these ones do, then I cannot, I'm pushing up, but it won't go anywhere, it won't slide off because of the lip on the glassware. Now it does talk about swirling it. And so if you heat something in a flame and you just heat it like so, you're not moving the solid. So kind of like when I was flicking the test tube to swirl it when it was a liquid, for a solid, I want to swirl. I'm going to do like a circular motion, like it's like a big loop, and I'm going to go in and out of the flame. So heating a solid in a flame, you don't just want to like put it in the flame and just hold it there. And you don't want to just like do it from the bottom, like rotating it. You want it at an angle, and then you want to swirl it. And I'm going to do this kind of at a faster pace where I know the image quality isn't great, but you can see that the solid is moving like and shifting up and down my test tube. So if I back this out, I'm going to swirl in and out of the flame, and then I'll bring it up and look at it. But I want to do it at an angle, and yes, I'm going to go in and out of the flame because this flame is plenty hot to heat it evenly, because I want the stuff that's in the middle to be heated, not just the stuff on the outside or on the bottom. So it's a good lab technique for this. But it's literally just a circular motion with my wrist. So for this one here, I'm going to do that motion now. And notice that I am literally just going in, and out of the flame. When you bang glass on the Bunsen burner, it does not like it. So heating this, swirling it, and then I'll pull it out here. Nothing that dramatic yet, but it doesn't hurt you to pull it out every, 10, 15 seconds and view it. Because I mean, I can't really see it any better than you can right now because it's being swirled, but you can see that white powder is going up and down my test tube. Now we can see something though. And I want you to see the other end of the test tube. So my test tube was dry, and now it's not so dry. gonna keep swirling it. So just like a little bit at a time. You know, if you're making observations, you don't want to heat something for very long before you pull it out and view it and it looks like it's alive. Okay, it's not alive, but it looks like it's alive. And then make your observation. So this is definitely the during. I'm going to heat it for, again, swirl a little bit. And again, just like a nice in and out of the flame. And that Bunsen burner is plenty hot to get to view it. And most of the time, students miss this one because they heat it too long before they pull it out and view it. And now that little, you see that big old chunk right there? Remember how this powder was not chunky? That is a big ball there that was not present before. So I'll heat it just a little bit more. Still alive. I'm going to take it out. Forms those like little grooves. And you've got that. It's like a little bit stickier to itself. And then the top of the test tube there, it's got all those. There you go. Now this one says a test with a burning splint. So I'm gonna light my splint here. Oh, that's no fun. Let me try it again. So sad. One more time. Oh. Now there is some yellowing. This is kind of the after. There you can see when I added this burning splint on the side of the test tube. Still some droplets on the side. And sorry, let me put the magnifying glass on so you can see. And then if I show you that little chunk there, and that's the full test tube. Now for cleanup for this, so some good lab techniques for cleaning this up here. Get this out of the way. So this test tube is pretty warm. It does say to let it cool down. So a couple things. You can put glass tubes directly on the slate table. It's perfectly fine to let them cool down. You would not want to put them on a plastic rack. I'll let you think about why. Or a plastic tray. A wood rack is okay, so I could let it cool right there. Now, if you're trying to see, is it cool enough to clean? All right, you don't ever want to grab, hot glass looks the same way as cold glass. You don't ever want to grab it with the front of your hand. You always want to approach glassware with the back of your hand, because the back of your hand is much more sensitive to heat. And so if you can feel it radiating heat with the back of your hand, then you don't want to touch it. Now, then you could gently tap it with the back of your hand. And if it's still really hot, the back of your hand is more sensitive. And this is warm, but not like super hot. And so as long as it's like cool enough to touch and hold, now it's not quite that, but you guys will wait. If it's cool enough to touch and hold, then it would be cool enough to clean out. So what you don't want to do if you just have a solid in your test tube is you do not want to add water to that because you don't know the solubility of that solid and you know how if the water is going to help or hurt. So it's always a good technique. If you've got solid and it says it's disposable, I mean, it can go down the drain, is to first just tilt your test tube and dump out, give it a little tap as much as possible before adding any water to the system. And then I'm going to add, this is hot water because this test tube is still warm and I don't want as large of a temperature difference. So I'm going to add tap water and then just rinse. And it's honestly sometimes easier to keep it in the test tube clamp to kind of clean. You're not getting your hand all wet either. And you typically just want to rinse with tap water until, you know, the test tube's mostly clear. Give it a look. Now this one is going to need a little scrub. So I'm going to add some soapy water here and test tube brush. and just kind of swirl this brush around. And this I'm probably going to have to hold now with my hand. And then rinse off my brush. And then rinse this really good until there's no bubbles. And you might be like, Ms. Bird, why are you showing this part? But honestly, like you guys learning lab technique and how to take care of glassware and putting it back how it is still a big part of chem. And so much like, you know, an AP question a couple years ago was asking about, you know, why shouldn't you add water to a solid in a test tube? Like, what are the potential, you know, things? Well, it was literally getting at solubility of a solid, in that not everything is soluble in water. And so, you know, they do talk about like little details like this. And rinsing with distilled water is not like filling this whole test tube with distilled water. So here I have the distilled water bottle. I'm literally just squirting like a little bit on the sides of the test tube, giving it a little swirl and then dumping it. That's rinsing glassware with distilled water. It's just like covering it a little bit, rinsing out any what would be remaining ions from the tap, because we know that there are some ions in tap, but there's not that many. Remember, it wasn't that conductive, so you don't need to go like ham on rinsing with distilled when you clean it with tap. Now, to dry a test tube, let's say you wanted to do like a second trial of this and it said you needed a dry test tube and Ms. Privet only gave you one. So you can wipe this down on the outside and get it dry. You could tilt it upside down and tap, but you still have some residue on the inside. So then what's a good way to dry a test tube? So you take a piece of paper towel and you kind of roll it. So let me put this down, roll it. And I'm not going to try and set paper towel on fire today, right? That's not the goal like last week. And so that it's narrow, because you don't just want like a piece of paper towel like this. It's not going to go in your test tube very well. And then you kind of have to push and twist the paper towel down into the test tube, but a narrow piece of paper towel will go down very easily. And then as you swirl it, it will cover all the insides and dry out your test tube, and it'll make it nice and clean and dry. So you just really push down to get the bottom. You can see that it's wet, it's at the bottom, and then pull it out. Now, this still has a little bit of water. So another way to quickly dry a test tube, if you've already rinsed it and everything, is to just heat it for a little bit and drive off the remaining water and let it, you can already see it's fogging up, but that's another way to drive off the water. Or get a second paper towel if you're not supposed to be using the Bunsen burner to dry glassware, because then it's hot again, it's very hot. Is you've got this one which is wet, roll up a second one and get it dry there. So just a couple lab techniques for you. That is station 4. Let's take a look at our station 1, and then we'll go back to, then we'll do station 5. See what station 1 is looking like. Okay, so here is, it's not so pretty anymore. So I wanted you guys to see it when it was. All right, so here is station 1, and this is longer than you guys would have viewed it. Okay, trying to get it in focus here. Plenty of the after. Now I'm going to tap this test tube to try to knock off whatever is seemingly growing. Hold on, let me do it. So you can get a sense of the texture of what's in here. And you can see the copper wire that was kind of engrossed in this is now, the stuff is at the bottom. There is it again. And for station 1 for cleanup, it says to, now you guys would just take your whole thing and dump it down. It says in a beaker that has a filter paper. So I'm gonna pull out though, because this is a much larger piece of copper metal than you guys would have had. I'm just gonna set that down. And then this is what I'm gonna dump. So if it says not to dump something down the drain, there's probably another area. And there you can see like the color of the liquid that was in there. Now, some of it did not come out. So I'm gonna add some distilled water to this and then dump it again. Hopefully it comes out. It does not. Add a little bit more. Get it, there we go, to come out. And this will filter out the solid parts from the water and the liquid parts there. And that is the after for station 1. Gives it away. It stays pretty for a little bit and then it's not so pretty. All right, station 5 says get a well plate. I switched it up from last hour. I got a better well plate. This one's a little bit deeper. I'll go show you the one I used last hour. There's different, wells, but it's like something, I can have opaque ones and ones that are translucent, like the one I just showed you. Different, it depends on like how big of a reaction do you want to do, what do you want to view. So this is the one I use, and you can just see the clarity level is much better with this one. So we're going to do it in that one versus I don't want this opaque one because I want to be able to look at what we're going to mix from the bottom and the top. And then I have bigger well plates that if you wanted to do more of something or have more surface area, you could do that. So just so you're aware of different, they're called spot plates or well plates. If you like to like do watercolors or stuff, then you might have seen something like that. Okay, so it says we're going to do 2 different reactions. The first one is with copper 2 chloride solution, so that's what this one looks like, and then mix it with potassium chromate solution. So copper 2 chloride, potassium chromate. Neither one has an odor. They're both at room temperature. Very flowy. They're not thick liquids. They're pretty thin. And I'm going to add a couple drops, that's 3 to 4, of the copper 2 chloride to a well plate. I'm going to do it in this corner here. 1, 2, 3, 4. Remember, you don't need a lot of something to see a reaction. And it's just sitting there in the bottom of that well. I'm going to add 3 to 4 drops of the potassium chromate here. It's after 1 drop. I'm going to show you with the magnifying view after 1 drop. Yum. Very thick. And then I'll add another drop. I'll add the 2 and the 3 drops there. All right, so we have, it's an orangey brown color. You can see some of the residue off to the right side of the well versus like more of it on the left. Just trying to show you guys from different views. Let me tilt up my phone so you can see the bottom a little bit easier. So that's like the bottom view of it. And I'll let it sit for a little bit and then show you again. But so from the side, whenever you're viewing solution, like a mixture of solutions, it's good to view it from all angles, not just what most students do is they just look at it from this view, okay? And you miss some of the detail. And like if I also move it, you can see that there is a residue there. And from this side, you can see the layering. There you can see kind of like a yellowish, oops, drop that, a yellowish layer on that's kind of on top of the red, brown, orange color there, and the residue there. All right, so that's that one. The other one says to take some silver nitrate, add it to a well, a couple drops of it. You guys have already seen silver nitrate, and add it to this corner. 4 drops of that. And then do it from the side here. Add a drop of the potassium chromate. And I'll just start with a drop and see what we see here. This is definitely an, I show both of these. This is definitely an oranger, orangier. This is like a really dark brown red here. And that's a side view. I'll try and tilt it up for you guys to get the top view of it, or I guess from the bottom up. So you can see like little balls of like stuff stuck together. Like another good technique is to tap, like tap this to see if anything kind of comes apart or forms together. And here is from the, this is with the silver nitrate and the potassium chromate. This was with the copper 2 chloride and the potassium chromate. And let me show you guys again from the top. Trying to get it as zoomed in as possible. Oh, there we go. Nice little residue there. That's the potassium chromate and the copper 2 chloride. And then over here, there we go. That's a good view. That's the silver nitrate and the potassium chromate. Very dark red brown there. From the side, you can see a translucent layer forming, starting to form. And over here, on this one, it still has like that. You can see there's definitely layering occurring. I'll let this sit for a little bit and then come back to it. I'm going to also add, because I only added 1 drop of the potassium chromate, I'm going to add my 4. I think I only added 3 to this one, so I'm going to add. Oh. All right, well, it's falling down. It's on the side, but then we'll let those sit and see if that does anything. There's not really like, you have the before and you have the during, and then we'll let it sit for a little bit and see if it looks any different, but it's kind of more of a later rather than, we're not testing for a gas or anything here. It's kind of like a later rather than an after. So come back to that one. Station 6 is another one where there's 2 reactions. All right, I gotta get one more test tube. So this one says take 2 test tubes and add 2 to 3 dropperfuls of hydrochloric acid. And so here I have my hydrochloric acid. And it does have a smell to it. It'll like kind of tingle your nose if you don't waft it. I'm not describing smells is not Miss Privet's like strong suit, but it does, if you don't know how to describe an odor, just describing it as like, oh, well, it's a strong odor, or it's a weak odor. And let me go grab a different dropper. This one was not working the best earlier. Different one here. All right, we're gonna set that one down. And this has hydrochloric acid residue, so I'm gonna set it down over to the side in the sink because I don't want to set that acid down somewhere where I'm working, because then if I put my hand down in it, well, remember, acid burns you from the outside in, base burns you from the inside out. I would know immediately if I had the hydrochloric acid on me because I would have red, itchy skin, and it would not be pleasant. But if you do, just rinse with a lot of water and it'll come off. Because the solution to pollution is dilution. If you didn't know that, now you do. All right, so there's the hydrochloric acid. Just grabbed my dropper from the sink that I'd set it down in, and I'm gonna close that back up. This one I'm gonna set back in the sink because I don't want to leave that on my tray or anything. All right, so we got the 2 dropper fulls. I'm gonna do the first one with adding some zinc. This is some zinc granules, and metals are stuff you can pick up with your hands and feel. It's got a, it's a very grainy. Let me do this. Let me grab some and then put the magnifying glass on there. So it's shiny, flaky. It's pretty smooth, the texture of it. It's fine, and there are some bigger pieces. Now you guys would probably have like a scoop that you would use. I'm gonna do a pinch with my fingers. Sometimes, you know, students take chemistry and they're like, oh, I can't touch anything with my hands. And it's like, well, you probably have some zinc metal like around your house, and you can definitely touch that with your hands. So I'm gonna do the zinc one first, and we'll view that. I'm gonna add a little bit more of the zinc here. This one's fun. So it looks like it's alive. Stuff is rising and falling. Oh, that's fun. For this. So there's definitely fizzing and bubbling that you can see. And it's, like I said, the test tube is slightly warm. And this one says to test it with a burning splint. So I'm going to do that here in a minute, but this is very satisfying to watch.
So is the stuff on the bottom like zinc plus bubbles? Like the solid looking stuff?
You definitely have bubbles. You definitely have zinc in here. And it's in the hydrochloric acid. So there are bubbles forming on the zinc because it's so fine, as I pointed out. The bubbles make it buoyant, which makes it fun. And then when the bubbles pop and are not in that solution, then the pieces fall back down. All right, so burning splint here. Get my splint ablaze and put that in there. There was a slight, I don't know if you heard it, a slight squeak, and this went out. It's still just bubbling away, and I'm going to leave this. Now notice this is foggy right now. I'm going to let it sit for a little bit, and while I do the magnesium one, we'll come back to it. Now for the magnesium one, make this a little bit more fun. I'm going to test the hydrogen, test the rather than test it in the test tube, I'm going to test it in the test tube, and I'm also going to hold this other test tube underneath it. Let me make this so you guys can see it. All right, so you guys have seen magnesium metal earlier in the lab. So I have my cute little baby beakers. I found the best thing for baby beakers are holding little pieces of magnesium or other solids. Okay, so another piece of magnesium ribbon here. Going to add this to the test tube here. There is a lot of bubbling. It sounds very much like a rocket ship taking off. And let me set this back down. It is very hot. It is hot to my fingers. That is definitely producing a lot of heat. Like so much so that I can't even hold it really down there. I need to hold it up here. And just trying to get like a view that you guys can see the magnesium there. You can kind of see it floating and it's bubbling. Now let me see if I can also do this with the magnifying glass. It's not going to be close enough. All right, well, I'm going to bring this over here, and magnesium piece is seemingly gone. It's no longer there. And let's test. I'm going to put the burning splint underneath this one. This one I was had under. Oh, that's fun. I'm also going to put a burning splint in, not that one, that one's toast, in the test tube here as well, and see if we can get something. Nice. Oh, it's so fun. Nice little squeak there. And you can see the fog, and that test tube there was clear before. And then this, let's see here. This has some wetness to it that was not there present, was not present before. And then also, so this was our test tube with the zinc and the zinc and the hydrochloric acid, and it was foggy, right? And I let it sit for a little bit, and now it's not foggy, and it's still just bubbling away there. There it is. This is the zinc and the hydrochloric acid. I'm going to test this one again with the burning splint now that it's not foggy anymore, and see if anything happens. Normally you can't test this one more than once because of the fogginess, but the fogginess has gone away. So let's see. Woo! Oh yeah. Ah, it's so fun. Okay, so that is kind of the after there. Now this one, though, with the magnesium is poof, disappeared. For cleanup, okay, if ever you have like a solid, and we're not going to let this sit forever, is to decant off, and I use the phrase the solution to pollution is dilution, because, okay, so this is acid in it. It's concentrated acid. So I'm going to turn on the tap lightly. I don't want it like streaming so full, and I'm going to fill this to the top with water, and then I'm going to decant. So I'm going to pour this off, just the liquid part, as I don't want to add a bunch of solid to the drain. So I'm going to do this a couple times to kind of wash and rinse the solid and just pour it off, but not enough. Like I'm not like angling it. Let me grab a different test tube. I'm not like angling it all the way down. I'm just kind of doing it horizontal. You can do that a couple times to dilute the acid, pour most of the liquid off. And then if you guys were doing this, you would, after you've rinsed it a couple times with tap, rinse it with distilled and pour off again most of the liquid. And now I'm going to add, and I was just doing it just to make sure I had like a full rinse. Now this, again, pouring off most of the liquid. What I'm going to do, I'm going to grab a paper towel here. And for solids, you know, it'll say like either put in a certain waste beaker or collect the solid remains in a paper towel. So then once you've rinsed it, you know, you don't have a bunch of acid in here, is you can dump this upside down, tap the test tube to collect the solid. And if it said to, you know, then toss the solid, you would do that, or whatever it said to do with it. It might say pour it through a filter paper like I was doing earlier. And then if there's still some solid left, you want to rinse it down to the bottom, collect it at the bottom, decant most of the liquid off. You want enough so that you can like pour it down the test tube and shake it out. This I'm going to keep, but you guys would then probably just toss this. And then you just rinse your test tube a little bit more, set it upside down to dry or whatever it told you to do. So that is station 6. Let's take a look at station 5 and see if our solutions have changed at all. Grab 5 here, bring it back over. So this would be the later for 5. And let's look at this one. So still the residue from the side. We've got more distinct layering. Looks like the red, orangey brown is like further down, and there's more of like a yellow layer on. That was again the copper 2 chloride potassium chromate. This is the silver nitrate potassium chromate. Now there's a slight yellow hue to it, and I remember I did add a couple more drops, but still a thicker residue here, the chunks. And from the side, let me try and get, here we go, a good view of the layers there. And then let me tilt my phone up so you can see the bottom view. All right. Kind of grainy. I'm trying to see if it's my phone or the, all right, that one just, oh, there we go. All right. So from the bottom, there, you can kind of see, I don't know why the focus is hard on this one, but you can see the yellow and the other part. And if I move them, the residue there. So that's 5. Now for this one, for well plates, for cleaning these, again, you don't want like a large stream of waters. You don't want whatever this is to splash, you know, with tap. So fill them up and then dump, and multiple times. Less is more. You don't need like a big like splash of water, because you don't know what you just made necessarily, and if you should, you know, be splashing into your face. And then for rinsing this, just squirt some distilled water in the wells that you used and dump. There. You usually set this upside down to dry on a paper towel. Now, if there's a residue, this one has a slight residue. Another way is to take a piece of paper towel, use a little elbow grease here, and just put the paper towel in there and kind of twist and to get any residue. There's no residue really on this one out, because you don't want the, let's see, you don't want it to look like this one, which has some like caked on stuff. Someone didn't clean it well from whatever insoluble thing was on that. Okay, so station 7 is our last one because you've seen station 8 like the whole time. And so station 7 is, we're going to take a piece of copper. And in this case, we're going to use a good old penny. All right. Now, you might be like, Ms. Pruitt, a penny is not pure copper. You're right. But the outside is pure copper. And that's all we're going to be heating is the outside. And so here's the before. This is a 2011 penny. Let's see if I can get the magnifying glass to show you the, here's Abe, 2011. You can see the gleam there. I'm going to heat this, see the back side of it. Heat this in the flame for about 20 seconds and then show you guys what it is after. So this, I'm not gonna try and heat it like in the super hot part of the flame, but I am gonna heat it until I see a little bit of a difference, and then bring it back over here for you guys to see. Oh yeah. So that's the back side. There's Abe. It's multicolored, tectonic, techno Abe. Now, I'm going to get another penny for comparison because, again, this is a good lab technique. Your eyes are very bad at remembering what stuff looked like beforehand. And so here is a penny not heated up. Here's the penny that I just put in the flame. Okay. Let me show you this side. Because this one says to like observe it for like a minute afterwards. This is 2015, but they're the same composition. And so you have a good comparison there. Normal coppery Abe, techno Abe. Normal Abe, techno Abe. Multicolored Abe. He's like, this is like evening Abe with his different colors. And then I also want to show you, I'm going to take, let's see if it's still hot. It's hotish. So you can feel it. All right, so I'm going to set it down on the slate for a second. Let it cool, but let me grab the penny that I was holding. So before heating, this feels smooth. Like there's definitely like grooves on a penny, but it's definitely smooth to the touch. When I pick up this one, okay, besides it being warm, it's like tackier. It's not as smooth. It's got like different roughness to it and like a stickiness, a little bit of a stickiness to it. And then this is the part that I had with the tongs here, and you can see that it didn't really get heated as much because it was covered by the tongs. And so this definitely has a different texture. Like they do not feel like if I was feeling both of these at the same time, like I would know that I would think I'm touching something different. Okay. Because it definitely feels different. Now as it's cooling, it is a little bit smoother and it's not quite as tacky, but it definitely was a minute ago. But this one is still definitely smoother than this. Okay. Anything you feel like you need to see or have questions on before we do notes? that's all that's all the stations, I believe. Okay. Fun. Seeing all those reactions? Okay. So again, some of the lab, in order to determine like what state of matter the products were after you predict them, is using your observations, okay? As well as like the rules and stuff that I've taught you, but you can predict a lot with your observations as well for this, rather than just like your guide to chemical reactions, which is designed to help you. So one of the stations though that has a nuance that you won't be able to, your guide will not be able to help you, is station 4. So station 4, we took sodium, hydrogen carbonate as a solid, and we heated it. All right. And in your guide to chemical reactions, it will talk about metal carbonates being heated, but it does not talk about metal hydrogen carbonates being heated. And there's a difference, okay? So you can look at what metal, this is in your guide, metal carbonates is in your guide. But metal hydrogen carbonates are a little bit different in what they do. So I want you to attempt to use your observations and what the guide says about metal carbonates to make a deduction about what the products will be for metal hydrogen carbonate. Come with your questions on that one tomorrow. You can also look up like what do metal hydrogen carbonates decompose into, but your observations can really help you with that one. Tomorrow I will go more in detail with this, but I just want to emphasize, if you're working on it tonight, this is the only reaction you really can't use your guide with because they don't mention hydrogen carbonates in there, okay? So there's that. Also in the post lab, in the next thing, so this is where the slides are on Schoology, is a different way to classify chemical reactions.